Hi students, this is a video on work problems. We're going to do a couple examples here. I want you to take notes on both of them, and then we'll go over it a little bit more in class when we meet next. Okay, here's the problem. We're trying to fill a swimming pool, and pump 1 can fill the swimming pool in 6 hours by itself. Pump 2 can fill the pool in 4 hours by itself. How long does it take to fill the swimming pool if both pumps are used at the same time? Okay, so this is a work problem. You've got two things doing the work. What is the work? Filling the pool. Okay, and so could just be two different workers doing something. In this case, it's two pumps that are pumping out water into the swimming pool. Okay, so what we're going to do is I tend to like to set up a chart and look at pump 1. Okay, so we've got number 1 and we've got number 2. Okay, so I like to work with this equation. The work rate times the time equals the work done. Okay, so if pump 1, right, fills the pool at 6 hours, so it fills 1/6 of the pool per hour, right, times 6 hours, you get one job done. So work done really means what part of the job is done. Okay, so it's a little bit tricky to think about it first. I think when you see a few examples, it'll be more clear. So what is the rate per unit of time? Okay, so if pump 1 can fill the pool in 6 hours by itself, its rate is not 6 hours. Its rate is how much of the job per hour does it do. So if it is filling the pool in 6 hours by itself, it's doing 1/6 of the job per hour. So it's really work rate per unit of time. Okay, per unit of time. So it's 1/6 of the job per hour. Okay, and then pump 2 is filling up 1/4, or is doing 1/4 of the job. We don't even want to say of the pool, 1/4 of the job per hour. So, right, if we don't write this down, but if we just multiplied this, right, times 4 hours, right, we'd get work done 1. 1 means 100%, the whole job. Okay, but let's get rid of that because now our chart is referring to what they're doing together, right? So the time together is what we don't know. How long does it take if both pumps are used? Be careful. This is the time let's make a note of that. This is the time together. They're working together. Okay, and we don't know what that time is. They're working together at the same time for the same amount of time, so they're both T. So pump number 1 is doing T over 6 of the work. Pump 2 is doing T over 4 of the work. We add the work together to get the whole job, right? We're basically finding the time till the whole job is done. So we're doing so we're going to set up an equation that looks like this. Okay, so we have the work done by number 1, pump number 1, plus the work done by pump number 2, and they're working at the same time, and they're going to get the whole job done, and we call that 1. Okay, kind of stands for 100%. All right, so the work done by pump number 1, right, we know is T over 6, excuse me, let me go back and fix that, T over 6, plus the work done by number 2, which is T over, remember we can have expressions stand in for things, T over 4 is equal to 1. And guess what we get to do? We get to clear fractions, yay! So you get to use something you learned earlier this year. Least common denominator is, out of 6 and 4 is 12, so we're going to multiply through by 12, and we end up with cross cancel, 2t plus cross cancel, 3t equals 12, and I get 5 My pen's not working. 5t equals 12. Divide by 5. Divide by 5. We get t equals 12/5. Oh my gosh, I've got a fraction. What am I going to do? I'm going to make a mixed number. Think about my units. 5 goes into 12. 2 and 2/5 time. So t equals 2 and 2/5 hours. Do we ever say I did something for 2/5 of an hour? Not really. So let's turn 2/5 of an hour into, oops, sorry about that, into minutes. We multiply the 2/5 of an hour by conversion factor. We want hours on the bottom, so that hours cross cancels out, and I get 2 times 60, which is 120, divided by 5. Minutes, 5 goes into 120. 24. Wow, I don't know why that just escaped me. Yeah, 24. So we get 24 minutes. That's this 2/5. So our final answer is, the time is 2 hours and 24 minutes. Okay, let's go on to another problem. Okay, next problem, a little bit trickier, and we're going to go through it a little bit quickly. 2 mechanics were working on your car. One can complete the given job in 6 hours, but the new guy takes 8 hours. They worked together for the first 2 hours, but then the first guy left to help another mechanic on a different job. How long will it take the new guy to finish your car? So let's set up our chart. Okay, so I have my chart. Work rate times time equals work done. Okay? So work rate, again, is per unit of time. We're talking about hours here. So if number 1, we'll just say 1 and call them 1 and 2. The new guy, 1 is the number 1 and 2 is the new guy. Okay, so 1 can complete the given job in 6 hours. So his work rate, remember, is 1/6 of the job per hour. The new guy takes 8 hours. He does 1/8 of the job per hour. Now, the time thing is a little bit different here. It's not just TT because they weren't working together the whole time. They worked together for the first 2 hours. Okay. So then the first guy left to do another job. So the first guy only worked for 2 hours. The second guy kept working. So he worked for 2 hours with the first guy, and then he kept on working for some amount of time that we don't know. So we're going to call that T, right? How long does it take the new guy to finish your car? That's T. So the work done here is 2 times 1/6 is 1/3, right? Okay, 1/8 times 2 plus T is 2 plus T over 8. Interesting. Okay, so this is the work done by each guy. Work done by number 1, work done by number 2. So remember, work done by guy number 1 plus work done by guy number 2 is equal to the whole job, is equal to 1. How come there's no girls working on my car? That's what I want to know. All right, so 1/3 is the work done by guy number 1 plus, I'm saying that the second guy who finishes is actually a gal. So gal number 2, the new one, right, finishes the car and gets 2 plus T over 8, part of the job done. And that equals the whole job because the job on your car gets done. Okay. Again, we are clearing fractions to get rid of the fractions. Okay, so multiplying through by 24, 24, 24, and cross canceling, I get 8 plus 3. I've got to remember to distribute 3T plus 6. Can everybody see where I get that? I'm distributing the 3 to the 2 and the T equals 24. Wow, I'm just changing colors all over the place. 8 plus 6 is 14 plus 3T equals 24 minus 14 minus 14. I get 3T equals 10, okay, divide by 3, and I get T equals 3 1/3 hour. I hope you guys can all divide an hour into thirds and find 20 minutes. T equals 3 hours, 20 minutes. Is that reasonable? I want to make sure I did this right and didn't goof up. 3 hours and 20 minutes. Let's look back. It took, the first guy can do it 6 hours. The second guy can do it in 8, right? They worked together for 2 hours and the first guy finished up. Sounds reasonable. It's not like 20 hours or half an hour, so sounds reasonable. We'll go with it. 3 hours and 20 minutes. All right, be ready to work on these problems in class on Monday. See you then.